This is the first section in Chapter 7, Energy, and in this section we'll actually define energy. Further discussions will talk about work and power and potential and kinetic energy, getting us into machines. Energy is one of the building blocks of the universe, and if you get into more advanced physics, we'll talk about the relationship between energy and matter. For our purposes, we're going to talk about energy kind of the same way that we looked at impulse. We talk about energy as what moves substances. Energy can both be a thing and a process, can be transferred or transformed, and also conserved. So the same way that we talked about the conservation of momentum, we'll talk about the conservation of energy. Another good thing to think about, and you're going to continue to see this pattern as we look at physics, if you recall in the last chapter, we defined impulse as being equal to force times time. Energy is another one of these derived situations, or energy is part of a set of derived equations, and we're eventually going to get to the idea that work is equal to force times distance. All right, so your first three chapters were basic elements in Newton's three laws. As we continue through these chapters on mechanics, we're taking our fundamental things with Newton's laws and mostly just putting them into all the different combinations that we can. And we're also playing with the idea of conservation, that before and after an event, things like energy or momentum are conserved. So for definition, when we talk about energy, it's closely related to the ability to do work. And work can translate into heat and light as well. And when we talk about matter, it's substance that we can see with our senses and occupy space. Energy is how matter transforms and turns into heat and light.